Imagine a future where our most secure encrypted communications are instantly decrypted, where battlefield simulations run millions of times faster, and where stealth technology becomes completely obsolete. This isn't science fiction anymore. We're on the brink of a revolution in warfare, powered by something most people barely understand: quantum computing. How will this mind-bending technology fundamentally reshape the conflicts of tomorrow? The next global conflict won't be fought just with tanks and fighter jets as we know them. It will be a silent war of algorithms and information, where the nation that masters quantum computing first holds an unimaginable, almost godlike advantage. Are we prepared for a world where even our most secure financial, military, and infrastructure systems could be compromised in an instant? Today, we're diving deep into how quantum technology is poised to redefine the very nature of modern warfare. So, what exactly is quantum computing, and why is it such a monumental leap beyond the computers we use every day? Traditional computers, from your smartphone to the most powerful supercomputers, work with bits. A bit is a simple switch, either a 0 or a 1. It tests a binary system that has powered our digital world for decades. Quantum computers, however, operate on a completely different set of principles, using what are called qubits. Thanks to a bizarre quantum phenomenon called superposition, a qubit can be a 0, a 1, or both at the same time. And through another strange property called entanglement, multiple qubits can be linked together in a way that their fates are intertwined, no matter how far apart they are. This allows quantum computers to process a staggering amount of information simultaneously. Instead of checking possibilities one by one like a normal computer, a quantum computer can explore millions of possibilities all at once. This isn't just a faster version of what we have. It's a completely new way of calculating reality. To put this in perspective, think about the history of military technology. The invention of the longbow changed medieval battles. The machine gun redefined infantry tactics. The aircraft carrier projected power across oceans, and the nuclear bomb created a new geopolitical reality. Each was a major leap. Quantum computing isn't just the next step on that ladder. It's like discovering a whole new ladder made of materials we didn't know existed. We are on the verge of entering a quantum battleground, and the rules of engagement are about to be rewritten from scratch. One of the most immediate and terrifying impacts of quantum computing is on encryption. Right now, almost all of our secure data, from your bank account details to top-secret government communications, is protected by encryption algorithms that are based on a very simple mathematical problem: factoring large numbers. For a classical computer, even a supercomputer, figuring out the prime factors of a massive number would take thousands, if not millions, of years. It's this difficulty that keeps our data safe. But for a powerful quantum computer, using an algorithm like Shor's algorithm, this problem becomes trivial. It could break our current encryption standards in a matter of minutes or hours. Imagine the chaos. An adversary could suddenly read every classified email, every military command, every financial transaction. It's just a concept known as Q-Day or the quantum apocalypse. The moment a quantum computer becomes powerful enough to shatter our digital security. This has kicked off a frantic global race, not just to build a quantum computer, but also to develop new quantum-resistant cryptography that can withstand an attack from one. But the threat goes beyond just breaking codes. Quantum technology will also give us new ways to see the invisible. Quantum sensors are being developed that are thousands of times more sensitive than any existing technology. These sensors could potentially detect the tiny gravitational or magnetic fluctuations caused by a submarine moving deep underwater or a stealth aircraft flying through the sky. The very idea of stealth, which has been a cornerstone of military superiority for decades, could become obsolete. There would be no place left to hide. This would grant an unprecedented real-time intelligence advantage, allowing a military to see and track enemy assets with perfect clarity. And then there's the evolution of cyber warfare. A quantum computer could not only break into protected networks, but could also analyze complex systems to find vulnerabilities that are impossible for humans or classical computers to spot. It could unleash cyber attacks so sophisticated and fast that they would be virtually unpreventable, capable of disabling an entire nation's power grid, financial system, or military command and control network in the blink of an eye. This is the new frontier of digital dominance. The power of quantum computing extends far beyond code breaking and sensing. When combined with artificial intelligence, it could create autonomous weapon systems with capabilities that are hard to even imagine. Think of a swarm of thousands of drones, all connected and communicating. A quantum-powered AI could process the enormous amount of data from all those drones in real time, allowing the swarm to make complex, coordinated tactical decisions faster than any human commander ever could. It could analyze the battlefield, identify targets, adapt its strategy, and execute a mission with terrifying efficiency and without direct human control. The same logic applies to robotic soldiers and other autonomous platforms, creating a battlefield populated by machines making decisions at quantum speeds. Logistics, the often overlooked backbone of any military operation, would also be revolutionized. War is a massive supply chain problem, getting the right resources, troops, and equipment to the right place at the right time. Quantum algorithms are perfectly suited for solving these incredibly complex optimization problems. A quantum computer could analyze a global supply chain, predict potential disruptions or enemy attacks, and calculate the most efficient deployment of troops and supplies with pinpoint accuracy. They could run countless what-if scenarios in real time, simulating the battlefield to predict enemy movements and optimize strategies on the fly. This turns warfare into a giant, high-stakes game of chess where one side has a super-intelligent advisor that can see every possible move 10 steps ahead. Unsurprisingly, this incredible potential has ignited a new global arms race. The world's superpowers, primarily the United States and China, are pouring billions of dollars into quantum research and development. This isn't just about scientific curiosity. It's a race for quantum supremacy. The nation that first develops a large-scale, fault-tolerant quantum computer will hold a decisive strategic advantage for decades to come. This competition is shaping global power dynamics, creating new alliances, and heightening tensions. The geopolitical landscape of the 21st century may well be defined by who wins this quantum race. But wielding such immense power brings with it profound ethical dilemmas. How do we control autonomous weapons that can make life or death decisions without human intervention? What happens if this technology falls into the wrong hands? The potential for unintended consequences is enormous. Some analysts believe that quantum computing could lead to a new form of mutually assured destruction, a quantum deterrent, where the threat of a devastating cyber or AI-driven attack is enough to prevent large-scale conflict. Others worry that it could do the opposite, enabling faster, more decisive, and potentially more destructive wars by removing human hesitation from the equation. We are walking a moral tightrope, and we need to have these conversations now, before the technology outpaces our ability to control it. So, how are nations preparing for this quantum future? Militaries around the world are actively adapting. They are investing heavily in research labs, partnering with universities and tech companies, and trying to recruit a new generation of scientists and engineers, quantum physicists into their ranks. They are simultaneously working on defensive measures, rushing to develop and implement quantum-resistant encryption to protect their critical systems before it's too late. But the story of quantum computing isn't just about the military. Like GPS, the internet, and so many other technologies that began with military applications, the advancements in quantum computing will eventually spin off to benefit civilian life. Quantum simulations could lead to the discovery of new medicines and materials. Quantum optimization could solve climate change and energy problems. And quantum sensors could revolutionize medical diagnostics. The same technology that could create an invisible weapon could also be used to detect cancer at its earliest stages. This is why understanding quantum computing is so critical for all of us, not just for generals and politicians. The development of this technology is moving at an incredible pace, and it will impact every aspect of our society. We need a robust public discourse about the rules and ethical frameworks that will govern its use. We need to ensure that as we unlock this unprecedented power, we do so responsibly and with a clear understanding of the risks and rewards. The quantum future is coming, whether we are ready for it or not. The real question is, what kind of future will we choose to build with it? Thanks for watching. If you found this exploration into the future of warfare fascinating, be sure to hit that like button and subscribe for more deep dives into the technologies that are shaping our world. Let us know in the comments what you think the biggest impact of quantum computing will be. See you next time.